The objective of this lesson is to have students use what they know about volume and develop situational equations in order to solve given problems. In previous lessons, students have written situational equations to find the volume of rectangular prisms. To find the volume of a rectangular prism, the area of the base is found by multiplying the length by the width. The area of the base is then multiplied by the height of the prism. Problem solving requires students to apply what they know to given situations. This application of knowledge requires students to think, reason, and grapple with a problem. The following questions may be helpful to guide children through the problem-solving process. What is this problem asking you to find out? What might the answer look like? How can you use your knowledge of volume to help you solve the problem? Would writing a situational equation help you find the answer? What strategies have you tried? Why did the strategies work or not work? How did knowing the volume of the container help you find the answer? Some problem-solving situations require one step. The following problem is an example of this type of situation. Candy Pop is a popcorn company that makes flavored popcorn. Which package would you recommend if the company wanted the largest box? Which package would you recommend if they wanted to ship in very small amounts? Students are given the dimensions of 5 different packages. The volume of each package can be found by writing and solving a situational equation for each package. The first package is 4 inches wide by 4 inches in length by 13 inches high. A situational equation could be written by multiplying 4 inches by 4 inches by 13 inches, which equals a volume of 208 cubic inches. Similar situational equations can be written for each package. Finding the volume of each package will help students decide which package would hold the largest box of popcorn and which package would be recommended if only a small amount of popcorn is shipped. Students are asked to justify their answers. A package with greater volume would hold more popcorn than a package with a smaller volume. Some situations require students to use 2 steps to solve the problem. Here is an example of this type of situation. 1 ounce of popcorn takes up 4 cubic inches. How many ounces of popcorn would each package hold? A situational equation to find the volume for each package is written. The situational equation for box C could be written as 7 inches times 7 inches times 7 inches equals 343 cubic inches. Each ounce of popcorn takes up 4 cubic inches. Taking the total volume of the package and dividing it by 4 will determine the number of ounces of popcorn needed to fill the container. 343 divided by 4 equals 85 and 75/100 ounces. Just over 85 ounces of popcorn would be needed to fill this container. The last type of situation requires students to use 3 steps to reach an answer. Here's an example of this type of situation. Paulo needs to buy frozen chicken for his restaurant. His chest freezer is 30 inches by 64 inches by 38 inches high. If he wants to fill half of his freezer with chicken and the rest with frozen vegetables, how many boxes of each can he purchase? A box of chicken is 19 by 16 by 10 inches and a box of vegetables is 16 by 19 by 5 inches. Begin by writing a situational equation to find the volume to fill the freezer. The equation could be written as 30 times 64 times 38 equals 72,960 cubic inches. Next, we would need to find out half of the volume of the freezer to divide between the chicken and the vegetables. We would need to divide the 72,960 cubic inches in half. The situational equation would be 30 times 64 times 38 divided by 2 equals 36,480 cubic inches for frozen chicken. Students will need to find the volume for each box of frozen chicken. An equation can be written showing the volume for the box of frozen chicken. 16 times 19 times 10 equals 3,040 cubic inches. About how many boxes of frozen chicken will fit into half the freezer? We will need to divide half the volume of the freezer, 36,480 cubic inches, by the volume for the chicken. 3,040 cubic inches. In the final step, we need to determine an equation that shows the total number of boxes of frozen vegetables that will fit into half the freezer. We know the dimensions of the frozen vegetable box is 16 inches by 19 inches by 5 inches. Half of the freezer volume is 36,480 cubic inches. We will need to divide that by the volume of the frozen vegetable box. The equation would be 36,480 divided by 1,532 equals 23 81/100 boxes. I cannot fit a part of a box in the freezer, so we can fit 23 boxes of frozen vegetables into the freezer. It is important to let children grapple with each problem, apply what they know about volume, and write situational equations to find solutions. Using the questions discussed in the beginning of the lesson can help guide children through the problem-solving process. The objective for this lesson was to have students use what they know about volume to solve given situations. We met this objective by writing and solving situational equations and using effective questions to guide children through the problem-solving process.